Imagine this. Actions taken in the final moments of the Challenger crew. Could they have survived the breakup?
Hi, I'm Allie.
And I'm Brianne. Hello.
So I had the weirdest night. I went on this ghost tour. A motion sensor went off in an empty hallway, and I swear I felt a cold spot just pass right through me.
Or, the batteries died and a draft existed. Sorry, not sorry.
Welcome to the Veil, Unsolved and Unbelievable, where we chase the mysteries anyway. Today we're talking about the Space Shuttle Challenger disaster. Heavy topic, I know, but it's a story with solid facts and questions that still, honestly, make my stomach drop.
Before anyone yells at us, yes, we know this isn't a whodunit. The technical cause is known, but there is a real mystery in those final minutes after the breakup. That part is unresolved and it matters.
Okay, here's what went down. January 1986. Mission STS-51L. Challenger's 10th flight and the Space Shuttle program's 25th. Millions were watching live, including so many classrooms, because teacher Krista McAuliffe was on board. The crew, Commander Dick Scobie, pilot Mike Smith, mission specialists Ellison Onizuka, Judy Resnick, Ron McNair, plus payload specialist Greg Jarvis and Krista. 7 people. A country basically holding its breath. It was bitterly cold for Florida. Ice on the pad, overnight cold soak, and here's the key engineering thing. The solid rocket boosters, SRBs, were built in segments with field joints sealed by O-rings. In that cold, those rubber O-rings could lose resiliency. They didn't spring into place fast enough when hot gases hit. Engineers at Morton Thiokol warned about this the night before. They initially said, do not launch in those temperatures. Then management pressure, a reversal, the final call went forward. That sequence got ripped apart later by the Rogers Commission. Liftoff at 11:38 a.m. Eastern. Within seconds, cameras would later show puffs of dark smoke from the right SRB's aft field joint. Probably hot gas blowby. Molten aluminum oxide from the propellant can weirdly form a temporary plug. The shuttle climbed. It hit wind shear, throttled through max Q, and around the 73-second mark, Capcom said, "Go at throttle up." Scobie answered, "Roger, go at throttle up." Then Mike Smith said, "Uh-oh." And that was it. A hot plume breached the right booster joint, impinged on the external tank, hydrogen pressures dropped, the aft dome separated. The tank failed and the stack was torn apart by aerodynamic loads. The SRBs flew on until the range safety officer sent destruct commands.
First in-flight fatal accident for a US spacecraft. It changed everything. Program halted for 32 months. SRB joints redesigned. NASA created the Office of Safety, Reliability and Quality Assurance. They moved routine satellite deployments to expendable rockets. And yet, years later, Columbia showed that culture problems can creep back in if you don't guard against them.
Okay, next up, the part that keeps me up at night. When Challenger broke apart, the crew compartment didn't disintegrate right away. It separated mostly intact and followed a ballistic arc. About 25 seconds to apogee, then roughly 2 minutes and 45 seconds down to the ocean. Unbelievably long if you imagine being inside. In the recovery, divers and ships scoured the Atlantic. Side-scan sonar mapped hundreds of possible hits. Navy and contractor vessels, submersibles, MV Freedom Star and MV Liberty Star out there. When they found the right SRB joint segment and later recovered it, that confirmed the breach. But they also found something else in the crew cabin debris that hints at human action after breakup. Those are personal egress air packs, known as PEEPs. They provide unpressurized breathing air meant for post-landing egress. Not ascent, not high altitude. At least 3 PEEPs were activated. And on the pilot's instrument panel, several lever-locked switches were found moved. Those aren't easy to bump. You have to pull against a detent and toggle them. Investigators tested whether breakup or ocean impact could do that. The answer came back no, which means someone deliberately moved them. Dr. Joseph Kerwin's report later said the evidence was consistent with possible post-breakup consciousness, but the exact timing and cause of death remain indeterminate. Mission Control lost telemetry. We don't know if the cabin stayed pressurized at all. We do know the impact was unspeakably violent and unsurvivable. But those minutes in between matter. Reach, twist, click. Someone tried, maybe to restore power or to get air to someone else. That gets me every time. It's not a single tiny anomaly. The peeps tell one story, the switches tell another. The last cockpit words tell a third. Mike Smith's "uh-oh" suggests awareness of a sudden, catastrophic change. Then silence. To me, that cluster of evidence is a deeper mystery. Not supernatural, but human. What exactly happened in those 2 minutes and 45 seconds? And who did what, trying to save who?
So let me get this straight. You're not saying they could have survived, you're saying the actions themselves are the mystery.
Exactly. The will to act when the odds are impossible. And the specific sequence we still can't reconstruct because telemetry was gone and the ocean destroyed so much evidence.
All right. Now, my scientist brain wants to lower the temperature a bit. Peeps give unpressurized air. At that altitude, without cabin pressure, consciousness can lapse in seconds. If there was any residual pressure, it might have extended that time, but Kerwin couldn't confirm it either way. And even if one crew member was conscious and moving switches, the ocean impact was unsurvivable. So the tragic endpoint didn't change. Also, on the cause, this wasn't fate or a curse. It was a known technical risk that people normalized. O-ring erosion had been seen since 1981. By 1982, they reclassified the O-rings as criticality 1, meaning no reliable redundancy. 1985 saw erosion on almost every flight, and one with erosion on both primary and secondary. The cold made the elastomer sluggish. The joint could rotate under pressure and compromise the seal. That's an engineering and organizational failure, not a cosmic one.
I'm with you on the cause. The thing I keep circling is the system around it. The night before, Thiokol engineers set a no-go below a certain temperature. Then after a management caucus, that changed to a go. Launch commit criteria didn't even include a hard SRB temperature limit. Media pressure was loud. People mocked the scrub the day before. That whole stew nudged decision-making toward launching in record cold. Conspiracy alert, but only in the human way.
No argument from me on the culture bit. Normalization of deviance is a real thing. The Rogers Commission hammered that. And the technical chain on ascent is brutally clear. Early puffs of smoke from the right SRB joint. A fragile aluminum oxide plug forming. Wind shear near max Q likely disrupted that plug. Then the plume reappeared around the aftertatch strut. Right booster pressure sagged. Hydrogen tank pressure dropped. Engines gimbaled to compensate. Then catastrophic breakup. The SRBs kept flying like two feral fireworks until range safety terminated them.
And the cabin was carried along. Thinking of them in there makes my chest tight. No ascent escape system. No ejection seats for a 7-person crew. If they'd had pressure suits and a glide escape, maybe. Though in this specific scenario, even that probably wouldn't have helped. But post-Challenger, NASA did add pressurized ascent and re-entry suits. They redesigned the SRB joints. They set up that safety office. Endeavour was built to replace Challenger and went on to do amazing missions. There was action after the grief.
And that's the lesson to drag into the light. Technical fixes plus cultural fixes. Because without both, you get Columbia later, another foam-shedding risk that people had seen before and rationalized. Different failure, same human pattern. If we're going to honor the Challenger crew, we tell that truth bluntly.
Back to the story. The unanswered piece is small in time but massive in heart. We don't know who pulled which switches or who turned on which peep. We don't know if pressure held for seconds or not at all. We do know human hands tried. That matters to me.
The point is, it shows something true about people under impossible odds, reaching for any control you can find. Breath, power, a switch you've trained on 1,000 times. That's not paranormal, it's profoundly human.
Totally. Human resilience is the real haunting here. It lingers. For a deep, careful look at all of this, watch Challenger, The Final Flight. It lays out the people, the tech, the choices, all of it.
All right, moving on. What are you doing after this besides chasing cold spots around abandoned buildings?
I'm actually heading to a stargazing night. No ghosts, just telescopes. If a UFO shows up, I'm calling you immediately.
Perfect. I'll be the one yelling it's a weather balloon while secretly hoping it's not.
Thanks for listening, friends. Be curious, be kind, and keep asking hard questions.
We'll see you next time on The Veil, Unsolved and Unbelievable.